function operations, you look at this really briefly in Algebra 1. This, of course, will be more complicated because, well, this is Algebra 2. We're going to look at how to add, subtract, multiply, and divide functions, and we're going to find what are called the composition or composite of two functions, okay? Really, all we're doing is, the big thing is we're saying, all right, you have one function like f of x and another function like g of x, and what we're able to do is we're able to add these functions, subtract these functions, multiply or divide all of these functions. It's really just that simple. One big key is that when we do this, one big difference after the operations is that we have to consider the domain of each function, and we'll talk about what exactly that means. The domain, we have to make sure the domain of a quotient function does not contain any x value for which the denominator, in this case g of x, would be 0. And that'll make a little bit more sense as we start to look at these problems. So if we wanted to look at adding and subtracting a function, so we have f of x right here is 4x plus 7, and g of x right here is the square root of x plus x. So if the question were to ask you, what is f plus g and f minus g, and what are their domains, all we have to do is literally, we're going to take the two functions right here, add them, and we get this. We're going to take the two functions right here, add them, and we get this, and that's it. The domain of f is the set of all real numbers. Okay, the domain of f of x is all real numbers. The domain, the easiest way to see that is if you look up here, this could be any number. It's a linear function. The domain of g is all numbers greater than or equal to 0 because it's under a radical, so we don't want a negative under there. So that's it. That's all you have to do. Okay, we subtracted them, we added them, and we made sure that the domains made sense. Go ahead and try got it number 1. Find f plus g and f minus g, and then talk about their domains. Go ahead and pause the video right here and find those. All right, you've unpaused. Let's see, for f plus g, okay, for f plus g, that's a plus, good lord. F plus g of x, that is 2x squared plus x plus 5, okay? And the domain for that is all reals. All right. For, let's change colors. For f minus g, so f minus g of x, okay, just slightly different numbers here. 2x squared minus x plus 11. 2x squared minus x plus 11. And again, the domain here is all reals. That's it. Easy enough, right? Let's take a look at multiplying and dividing functions, and this is where the domain might get a little more complicated. All right, so multiplying and dividing functions, a little bit more complicated with the domain. Same idea. We give you an f of x right here, give you a g of x right here, and then we ask you to multiply them and divide them and talk about their domains. Okay, so to multiply, use FOIL or the Punnett squares or whatever it is that you like, and we get this right here. We divide. To divide, we're going to factor the top, and so we end up with this divided by that. We're able to then divide those two out, and we're left with just x minus 3. Big key here is that we do have to make sure x cannot be equal to negative 3 there. Okay, the domain for both f and g is the set of real numbers. So the domain of f times g is also the set of real numbers. So this one's easy. That's all reals, no problem. Okay. The domain of f divided by g is the set of all real numbers except x can't be equal to negative 3. If x is equal to negative 3, the denominator is 0. Okay. So we have to look at the original, even though we simplified and got here, we have to look at what was it when we substituted everything in. What was it here? And make sure that x is not equal to something that's going to make it equal to 0, the denominator equal to 0. Okay, so let's go ahead and pause the video here. You're going to try, yikes, you're going to try got it number 2 right there on your own. Again, f times g, we need an answer for f times g of x, and we need an answer for f divided by g of x. Go ahead and get both of those, please. Pause the video here and get those. Make sure you account for the domains. All right, so you've unpaused. F times g of x is 9x cubed minus 30x squared minus 23x minus 4. Okay, if you didn't get that, make sure you pause the video and go back, rewind, try again, see if you can figure out where you messed up. You wouldn't actually rewind because you're not a robot. The domain here is x is an element of the reals. All reals is fine. And then f divided by g, we get just x minus 4. Okay, big difference here is that the domain, x is an element of the reals such that x is not equal to negative 1/3. Okay, x can't be equal to negative 1/3. Again, if you didn't get those, I would go back and try them again. You really want to get these answers correct so you know what you're doing. Okay, a composite functions. We're going to talk about composite functions next. And this kind of picture right here gives you kind of like a clue. The domain of f right here, and the range of f, and then all these input-output things, and we end up with getting this down here at the bottom, the g of f of x. Okay, when we combine two functions like we do right there, that's when we form what's called a composite function. So the composition of functions, of function g with function f, is written as g, and then it's like an open circle f, and it's defined as g of f of x is equal to g of f of x. Okay, which sounds complicated. It's not. It's really just using the parentheses in order of operations. I think this is much better right here with the colors. We're going to find f of x first. Then, whatever that is, we're going to plug that into g of x and solve for that, or simplify for that. The composition function is not commutative because these two will not always be the same. Okay, they will not always be the same. Sounds complicated. It's not. Let's take a look at what it looks like. There's two different sort of methods they show you. So here's f of x and here's g of x. And the question is, what is g of f of x? That's how we read that. What is g of f of x? And I think looking at it like this is sometimes confusing. I think this is much better. Okay? So what we're going to do is we're going to take f of x and we put that in right here where the x is. So this is g of f of x, and f of x is just x minus 5. The g is all of that squared. Okay, the g is all of that squared. Oh, and we're finding it for negative 3. Okay, so we plug the negative 3 in right here. Negative 3 minus 5 is negative 8, and negative 8 squared is 64. Okay, so we took our f of x, what that was right here, we substituted it in right there. Okay, then g of x was x squared, so whatever this is squared, that was g of x. And then we substituted negative 3 in. That was method 1. Method 2 is really similar, and for some of you, you're going to be like, wait, that's the same thing. We're actually going to take the negative 3 and we're going to plug it in here first. Okay? And actually, we'll change colors. So for this one, we're going to take the negative 3 and we're going to plug it in here first. Get negative 8. Okay, right here, and then plug negative 8 into the x squared, and we get 64 that way also. Go ahead and pause the video right here and see if you can get, for the same for the same two f of x and g of x, do f of g for negative 3. F of g for negative 3. Go ahead and pause the video here and get that. All right, hopefully for that, you got 4. If you didn't get 4, pause the video, try it again, see if you can find your mistake, maybe a sign error or order of operations or something like that. Take a look at problem number 4, using composite functions. So if you have a coupon for $5 off a large pizza, but you also get a 10% discount on any pizza when you show your ID, we're going to have both of those, and that's going to be two different things, and we're going to combine them. And this combination of the two is a composite function. Okay, how much more would you pay for a large pizza if the cashier applies the coupon first? Okay, so if they do the coupon first, we want to look at what's the difference. Okay, so if x is the large pizza, okay, that's the price of the large pizza. The cost using the coupon is just x minus 5, okay, because it was $5 off. The cost using the 10% discount is just, it's x minus 0.1 or 0.9x because it's 10% off. So what we want to know is we want to compose the functions c of d of x and figure out what that is. Then, step 3 right down here, we're going to do d of c of x, find out what that is. Then we're going to subtract the functions to find out how much more we would pay if the cashier applies the coupon first. And the answer to that is, when we subtract all this, is we get 0.5, so the answer is 50 cents. So if the cashier applies the coupon first, we pay actually more. So the order that we do that in matters. All right? So let's take a look at, what if we have a store offering a 15% discount on all items, and employees get a 20% discount? So first, write composite functions. So let's write a function to model taking the 15% discount and then the 20% discount. Let's model the 20% then the 15%. And if you were an employee, which discount would you want to take first? Okay. So let's take a look at this. We'll do this one step at a time. So number 4, we're going to say let's do discount for the store discount of 15%. Okay. So we'll just call that d of x, just a regular discount, and we'll say that because it's a 15% discount, we're going to say that that's 0.85x. Okay, so 15% minus 100% is 85%. Then let's say the employee discount, and we haven't started A, B, or C yet. I just need to have 2 functions to work from, is 20%. So that's 0.80x. Okay, so now I'm going to do some setup here for you, but then you're going to do the math. I'll help you with part A. E of D, of x equals, you need to find that. Then you're going to find d of e of x. You need to find that. And then you're going to figure out, if you were an employee, which one would you want first? Go ahead and pause the video here and get that information. Pause the video now. All right, you've unpaused. Let's see what you got. Hopefully for this, you got 0.68x. And for this, you got 0.68x. So the answer here is it doesn't matter because they're the same. So it doesn't matter what order we take those discounts in. Those are the same. Ooh, you don't even need that. That's it for the notes, guys. All right, again, so it doesn't matter. They're the same. That's it for the notes. I will see you guys next time. Bye.